Good morning. Today we're going to be doing lesson 16, understanding box plots. Before we get into the actual lesson, I want to give a quick variability lesson on box plots. So right here, I also noticed yesterday a lot of you were asking, is a box plot the same thing as a box and whisker plot? It's the same thing. The reason why I call it a box and whisker plot is because you have your box and then you have whiskers on the side. Two different names mean the same thing. So these are four common different types of box plots that you see, that you create when you're describing data. And I want to talk about what variability means in terms of these different types. So let's look at number one. The smaller the box, the lower the variability. Now, the lower the variability, the more accurate your data median will be, and your mean and all that stuff to represent that data. So you want lower variability. You also want small whiskers. The reason that means is that there's less outliers to skew your data. When there are a lot of outliers, these lines are really long, which means that your data might not be accurate in the middle as much as you'd want it. So something like this is low variability. It also means that the data is clustered around that median, around that mean. That's what you want. Now here, there is low variability because the box is small. Boxes are typically what we mean in terms of variability. That's what we're looking at. Oop, I ran out of room. But you can see that our whiskers are really long. This means that there are outliers. And we don't really want those. That skews our data, that changes our data. It changes the way we look at it. For number three, big box, it has high variability, but it does not have a lot of outliers. And you can tell that by the small whiskers. And fourth, you have high variability with outliers, which is definitely not what you want. That means the data is super spread out. The data doesn't even correlate with each other. Okay, now we're gonna dive into the lesson. A lot of this lesson you're gonna be doing today is actually gonna be by yourself. You're applying the skills that you've learned to the problems. The first exercise talks about the Supreme Court. You're gonna be dealing with minimum, you're gonna be dealing with maximum, you're gonna be dealing with the median, and then I want you to look at letter C. You need to make a box plot for the year. So you need to draw a plot diagram, and then you need to do the box plot as accurate as you can above it. Some of you don't match up your box plot with the numbers. You need to. And then we'll say describe the shape of the distribution. Is it symmetrical? Is it skewed right? Is it skewed left? And how does the median and the IQ relate to the box plot? Is the median actually the center of the data? Is there a lot of outliers? So that's kind of what we're talking about. Is the IQR small? Remember, you want a small IQR. Typically, if it's 10 or above, that's a very high skewed data, but you should also be able to tell by the size of the box. And then D is the median halfway between the least and the most numbers. So is it in the center of the data is what it's asking. And then you need to say why or why not. So for exercises 2 and 3, it's talking about different song lyrics. Really, the only thing that I want you to do is I don't want you to do 2, A and B. I don't want you to do C, but I do want you to answer D. I think that this is a very important question for you to get across, is what are the advantages of using a box plot to summarize a large data set? And what are the disadvantages? So what are the pros? What are the cons? All right. And then secondly, you're looking at Molly, who has a broadband connection, which is dial-up, and she argued that the dial-up connection has less variability than the broadband. So broadband times. I don't really need you to do this one because I think the rainfall one is a lot more beneficial for you. So the rainfall one, I want you to do 4, A and B. So you are looking at two different sets of data, St. Louis and San Francisco, but this time you're not looking at temperatures, you're looking at rainfall. I want you to answer A and B, and I just wanted to point out that conjecture means prediction. Conjecture means prediction. Then for number 5, you're using exercise 4. So you're using what you were doing in the rainfall, and you need to create 2 box and whisker plots. Again, they need to be accurate. All right, you need to use the data, and you need to make this for the rainfall. St. Louis on top, San Francisco on the bottom. Then you're going to answer 2 questions. Compare the percentage of the months, and then how does the top 25 of the average monthly precipitations compare? So top 25, that's that right whisker. It's the whisker on the right. How do the 2 of them compare? E, I would also like you to answer, think about the dot plots and the box plots. Which representation do you think most helps you understand how the data varies? All right, look at how much data is being represented. Which one do you think you can see the data more accurately with? For your homework, I want you to do 1, A, B, and C. And then I want you to flip it over. And then I actually want you to do 2, A, B, and C. Oh, and D. And then I do not want you to do 3. And I do not want you to do 4. So all of 1 except D, but all of 2. All right, get your lesson checked. Then you can grab your exit ticket. Then you can start on your homework. Raise your hand if you have any questions.